Today's lesson is on nth root and rational rational exponents. So I'm going to show you how to change back and forth from radical to rational notation. So radical notation, we got the square root, right? But it could be a square root, it could be a cube root, it could be a fifth root or a 10th root. Now this number right here, the index, is what tells us what kind of root it is. If there is no number there, then we assume that it's a square root. If there's a 3, it's a cube root, a 4, a fourth root. But if there's nothing there, we need to know that really there's a 2 inside that index. So radical notation looks like this. Some root of something, maybe to a power. And we're going to change it to rational notation. X to a fractional exponent. So this m and this n correspond with this m and this n. So I've got my root goes down here, and my power goes up here. Now there are a couple ways to help you remember where the root and where the power go. I found this one, which is kind of silly and cute. You've got your radicand, which is what's inside the radical, to some power, and the root. So this root is like the goatee. Got a little goatee here, and we've got the eyeballs as your power. So if you like the eyeballs and the goatee, maybe you can use that to help you remember where each part goes. I personally like the flower. The flower works for me because roots, I think of roots, and flowers have roots. And then we've got flower is the power. So we've got something to a power, and it's that root. So the root, when we put our flower together, we've got the power goes on top, just like the flower, and the root goes in the denominator. So this might not make any sense right now, but we're going to go and practice a couple problems, then come back to this and it'll make a little more sense. So here we go. So this is just the same notation, different notation, but the same exact thing. Some base to a fractional exponent is the same as taking that root and putting it in the root, so the nth root of b. So let's say I had 8 to the 1/3 power. Well, that's going to equal the third root of 8, which is asking what times what times what gives me 8. Well, another way is change that 8 into 2 cubed. The cube root of 2 cubed is 2. A cube root and a cube undo each other, and our answer would be 2. Alright, let's try some. So if I had to change okay, what is that again? If there's nothing there, it's just going to be a 2. So I might even write in that 2 just so I remember that there's a 2 there. I want to change this radical notation into rational notation. So my index, my radicand, what's inside the radical, is my base. And when I do my power, this is my root, that's my power. So the power goes in the numerator and the root goes in the denominator. So this notation is equal to this in rational notation. And we need to be comfortable going back and forth to either of these notations. Let's try this one. So I keep my base. My base is 2. This is my power, and that's my root. To the 5th power, but it's being divided by 4. So this would be radical notation, this would be rational notation. It's important that you practice saying those words. Here we've got this whole quantity. So if there's a product in here, it needs to be this whole thing, 3a, to the power of 4, but it's got a root of 3. So we want it divided by 3. So the quantity 3a to the 4/3 power. Here, again, there's nothing here. There's no index. So I know that that is a 2. It's a square root. So again, this whole thing, 6p to the 1/2 power. Notice there wasn't any number or power here. So this is really p to the 1 and 6 to the 1, so it becomes 1/2. In this situation, we're in the denominator. Now, we're going to use what we learned in the last lesson. So this is my 3k is my base of my exponent. We're going to take 3k. Now this is a 2, so I've got 5 halves, right? 5 is my power, 2 is my root, but in order for me to get it 1 over, I use a negative in the exponent. So it ends up being the quantity 3k to the negative 5 halves. Let me write that one more time. Looks a little sloppy. 3k to the negative 5 halves would be your answer. So this is radical notation, this is rational notation. So now if we go backwards, or take something in rational notation and change it to radical notation, I want to say, okay, well this is my power and that's my root. So that's my root and this is my power. Okay, so I'm going to take 2. 2 is what goes inside. That's my radicand. My power, I can put it in here, or I'll show you another way you can put it. And the 3 is my root. So my power, my root. I could write it like that. Another way of writing it that means the same exact thing would be like this. This whole quantity to the 5th power. Either of those is acceptable. So again, this whole quantity, let's just try a couple. 10n. It's a square root, right? That's my root. Square root to the 3rd power. I'm going to put this whole thing in parentheses. To the 3rd power. All right. Now, I want you to notice the difference between this problem and this problem. They're very, very slight difference in those two problems. Here we have this whole quantity. Here, that 3 halves is really only applying to that n. So you have to be really careful. This 10 is not being subject to the 3 halves power. So we get 10 square root of n cubed. You could also write 10 square root of n cubed. Either way would be fine, but you need to make sure that that 3 halves power only applies to that n because that's what it's touching. Notice here, 3 halves power applies to both because they're inside the parentheses. All right, we're almost done. We got 1.5. We could change that to a fraction. 1/2 would be 3 halves. So we could change that and then do exactly what we've been doing. So square root of 6v to the 3rd power. And then a negative, just like up here, that negative tells me it's going to be 1 over m to the 1/2 power. Well, that's my root and that's my power. So I do a square root and that would be what I get. All right. Lastly, I have, it says find the 5th root of 32, which is really just asking 32 to the 1/5 power, or the 5th root of 32. And what it's asking is what times what times what times what times what? 5 times is being multiplied to get 32. So if you want to do like a factor tree, or you want to rewrite 32 as something to the 5th power, if you can, that's your goal. So is it 1 to the 5th power? No, 1 to the 5th power is 1. How about 2 to the 5th power? Let's try it. 2 to the 5th power, yep, is 32. So the answer then is to the 5th root of 32 is 2. Find the 4th root of 16. So you could, if you want to check in your calculator, you could put 16 to the 1/4 power. And you would find that it is also 2. 2 times 2 times 2 times 2. 2 to the 4th power gives you 16. So the 4th root of 16 is 2. All right, if you want to try a couple of those, that would be good. Try a couple. And lastly, evaluate each expression. So again, this is just the way to read this would be find what's the 5th root of 32. We just did that. The 5th root of 32. Maybe I'm more comfortable doing it like this. The 5th root of 32. I could change that into radical notation in order to C. Oh yeah, that's what they're asking me. What times what times what times what times what gives me 32? It's 2. All right, again here you could write, well, what's the cube root of 27? Which is asking, what number times what number times what number gives me 27? I need some number multiplied to itself 3 times to get 27. And 3 times 3 times 3 gives me 27, so we would get 3. How about 81? 81 to the 1/4. Fourth root of 81. So I want to break down 81 and I want to say, okay, well 81, I know it's 9 times 9. And 9 times 9, well, that's 3 times 3, and that's 3 times 3. So if I had to rewrite 81, I could rewrite 81 as 9 squared or as 3 to the 4th. And in this case, I want to write it as 3 to the 4th because I'm doing a 4th root. So the 4th root of 3 to the 4th, these cancel out and I get 3. All right. So let's look at this one real quick and then I will let you go. 27 to the 1/3 times 27 to the 5/3. Now notice we have the same base, so we're going to still have the same base, 27. And when we have the same base, we're going to add the exponent. So 1/3 plus 5/3 is 6/3. Well, 6/3 really simplifies to 2. So we just get 27 squared. And we would find out what that was. You could also, there are lots of ways to do this. You could find the cube root of 27, which is what that's asking. The cube root of 27 is 3. And then I could also find the cube root of 27, which is 3 to the 5th power. So 3 to the 5th power. So our answer would be 3 times 3 to the 5th power, which is 3 to the 6th power. And these should give the exact same number. All right. Okay. I believe that is all I have for you. Here are some answers. So if you want to check some of your answers, that's awesome. All right.